everyone, in this video, we will explore one of the key new features of ProtaStructure 2024, new frame members and frame groups. Also, we will have a step-by-step tutorial on how to model these frame members. Let's start with the Frame Members menu. The menu is under the Modeling tab of the ribbon menu. Here you can see all the steel members that you can model with frames, steel beams, primary and secondary composite beams, Girts, Purlins, horizontal and vertical braces, and frame group. Through this menu, you can select the steel member type that you want to model and start the modeling process. Let's see the process live. Now, we will redefine this steel beam and take a closer look at the Properties window. Here on the top, you can see the label setting, which you can adjust by simply clicking on the arrows on the right. Under the label, you can define the member type of your frame using the drop-down menu. Then, you can manage the section properties. For this purpose, you can take advantage of the extensive section library of the ProtaStructure. The next step is to define the section reference anchor. This feature is essential, especially when you change the section. Let's look at the use of this feature through simple examples. Now, while the section reference anchor is set to be top center, we are changing the section with a larger one. As you can see on the model, the section is enlarged in the downward direction while taking the top center as reference. Now, let's change the section reference anchor. Select bottom center and change the section again. This time, the section is enlarged in the upward direction while the bottom part remains the same. Let's continue exploring the Properties window. The next setting on this window is the angle. This setting allows you to turn the member around its center line. Instead of entering the angle manually, you can set the angle by using another member as a reference. It is a simple process. Click on the button and select the reference member. Then, the angle will be set automatically. Let's reset the angle and move on with the next setting. Using this part of the Properties window, you can manage the degrees of freedom at each end of your member. Here, the member has pin connections at both ends. By using this button, you can easily shift from pinned to fixed connections and vice versa. After defining the end conditions, here, you can decide to insert your frame either straight or curved. When you select the curved option, there are two additional settings that you need to adjust: plane normal angle and apex distance. Apex distance is the distance between the top and the bottom of the curve. Let's check it out on the model. Here, you can see that the member is curved, and you can change the direction of the curved member by adjusting the plane normal angle. Plane normal angle is equal to 0 by default, which means that the member is curved horizontally, or you can adjust it as 90 degrees to curve the member vertically. The third option is to curve the member based on an angle input that you manually define. The shortest way to remember the function here is that the angle you enter is the angle between plane of the member and the XY plane. Let's set our member as a straight beam, and move on with the 3D tab of this window. On the very top, you can see the analytical offsets. By entering values here, it is possible to move the I and J ends of the frame member in X, Y, and Z directions. As you can see, we moved the I end of the frame 1 meter in the positive X direction. While doing this, we moved the analytical wire as well. On the other hand, the physical offset values manage the position of the physical member only, without changing the analytical model, which can be seen here. While the member is moved, the red dashed line showing the analytical wire remains the same. Analytical wire reference point controls the position of the analytical wire on the physical member, and there are 9 options for this setting. Now, we select bottom center and click Update. As you can see, the analytical wire is moved to the bottom center and the physical model is adjusted accordingly. The next setting is the supports. In order to show this one clearer, we will move the section upwards analytically and release the ends of. Using these drop-down menus, we can assign supports to the ends. After you update the member, the supports can be seen on the physical model. At the bottom of this tab, you can see the vertical-only member feature, which is developed to comply with specific design codes. When this box is checked, the member is designed considering only the vertical loads, and the lateral loads are neglected. Also, you can manage the load combinations to be considered for the vertical loads only members through the load combination editor. The design will be done for the selected load combinations. Let's talk more about the member end conditions and supports. First of all, we can define the support types by utilizing the Support Types command on the Modeling tab. On the left-hand side you can see the existing support types, and you can define a new one by clicking on this plus button. Utilizing the fast restraints, you can effortlessly define the restraints in global directions. When you make your selection, the restraints in global directions are updated automatically. Also, for the directions in which the end is free, you can define a spring stiffness. In order to explain the end conditions better, we will model steel beams. When you wait a moment on the member, an info box appears, and the end conditions can be checked here. When you check the Properties window, you can see that the J end of this beam is really free. During the modeling, if one end of the beam is free, ProtaStructure detects it automatically and makes the necessary settings accordingly. However, we still recommend you to check the end conditions yourself. Now, we will show you how to change the properties of these steel beams together. Select both members, right-click, and select the Edit Sections/Materials option. By making the adjustments on this window and clicking Update, you can easily change the sections of these beams at once. Also, after selecting the members and selecting Properties or Member Tables option, you can open the Frame Member Table. On this table, you can manage the types, offsets, and other settings of the selected members together. As you change the settings here, your selections are applied automatically. Now, it's time to have some hands-on experience. Let's see all the features we have mentioned so far in action. We will insert vertical brace frames into our hangar building. We are now starting to model the vertical brace frame at the bottom end of this column. While pressing the control button, we look for an appropriate point to insert the other end of the brace. Let's change the section now by using the Properties window. Now by repeating the same procedure, we will insert the other brace frame. At this stage, we get a warning about the intersecting members. We say yes to make the braces we inserted divide into two pieces from the intersection point. We apply the same procedure for the upper part as well. Now, we will model the same system for another part of our hangar building. For this purpose, we will utilize the Copy and Paste command. First, we select the members that we want to copy. Then, we select the Copy option on the right-click menu. Lastly, we select a reference point and paste members as shown here. Let's move on with the platform inside the building. First, we switch to the plan view. We start the process with modeling steel beams. On the frame menu, we select the steel beam, and we change the section by utilizing the Properties window. Then, we insert the steel beams by taking advantage of the smart points. Again, the software sends a warning message about the intersecting members. We want to make the beam divide into pieces. Now, we insert horizontal brace frames into the platform. We simply use the command and insert the brace frame. Let's take a closer look at our horizontal brace in 3D view. As you can see, the brace is inserted at the same level as the beams. By utilizing the Properties window, we will rotate the member and adjust its physical offset to change the level. Finally, we have our brace as we want, so we can turn back to the plan view and model the other braces. Now we select all the beams and the braces we modeled, and using Mirror command, we will insert the same members to the other side. We select the Mirror command on the right-click menu, specify the symmetry axis, and execute the mirroring. Lastly, we check our model in 3D view, of course. Let's continue with the purlins now. We will insert purlins into these two openings with frame members. Select the command on Frame Member menu and start modeling the first member. Of course, first, we choose the section. Then, using the analytical points of purlins, we insert our member. We adjust the member utilizing the Properties window. Now we can copy this member and insert the other purlins. This opening is for chimney, so we will insert perpendicular purlins to define the boundaries of the chimney. Now, around this opening, we can insert the rest of the purlins. Let's mirror all these members to the other side. Remember the process: select the members, choose the command, define the symmetry axis, and mirror. Finally, we have the purlins and the chimney openings on the roof. Another steel member that we can model with the frame members is Girts. We modeled these Girts by utilizing the Girt macro. However, as you can see, there is an opening here. It is because the macro doesn't work perfectly in such conditions. Don't worry, we can easily insert Girts here in this triangular part. We will insert the Girts between the steel beams of the roof. For this purpose, we select the Girt frames, adjust the section settings through the Properties window, and start modeling. We adjust the position of our Girt using the Properties window. In order to specify the required offset value, we use the Measure command. As you can see, the distance between the members is 15 centimeters. Adjusting the physical offsets, we will take care of this situation. Now, we can model the rest. We will follow the same procedure for the other side of the building. Here in this gap, it should be a door and a window opening. Let's model those with frame members now. We select Girt frame for this purpose, and adjusting the properties, we start modeling. First, we adjust its position utilizing the physical offset values and reference points. To determine the required out-of-plane physical offset value, we use the measure command again. Then, we model the other Girt frame and adjust its section angle. Now, we can model the outer part of this door opening. We simply place our frame members and adjust their positions and section angles using the Properties window. After we model the first two Girts, we utilize the copy command to model the rest. Now, we have our door opening modeled with frame members. We can continue with the window opening now. To model the window opening, again we use the Girt frames. Let's model the Girts in the bottom part quickly with the frame members. Now, we will model a cantilever canopy above this platform. First, we copy this beam by using the Generate Members to Other Story command in the right-click menu. After copying the beam to the third story, we adjust its end conditions and move the beam to the end of the column. For this cantilever canopy, we want to have curved beams. Hence, we go to the Properties window and change the insertion method as curved. After selecting the curved option, we enter the required parameters. However, as you can see that for the J-end of our beam, the connection to the column is a bit problematic. To solve this issue, we use the analytical offset settings. Now, everything looks fine. We copy the beam to the next column using the column ends as reference points. At the eye-end of these beams, we will insert another frame member. Copying all these members, we complete the main form of our cantilever canopy. Now, let's insert frames between these beams to enhance the stability. For this purpose, we utilize the Frame Group command. First, we assign its type and adjust the section settings. We enter the quantity info, and we check the generation options. Here, it is set to remove the first and the last element of the group. Selecting between two members option, we insert the frame group between these curved beams. As you can see, the group is inserted. The Frame Groups command is introduced with the ProtaStructure 2024, so let's take a closer look at this Properties window. At the top, we have the label again. Below that, we have the Type section where we can manage the type of frames of our group using the drop-down menu. We can manage the section properties using this section. With the section alignment setting, we can adjust the frame group's position. Now, we select the centered option for our frame group. In the generation method part, you can control the quantity or spacings of frames in the group. Also, you can explode the group by using the corresponding command on the right-click menu to have individual frame members. Let's continue with copying these frames to the other parts of our cantilever canopy. Lastly, we will insert steel beams to this platform. Let's switch to the plan view. In order to make our job easier, we turn off the visibility of braces. To model the beams in this part, we will use the frame groups command. We assign the type, adjust the section settings. Before inserting the members, you can check your adjustments with this preview. We can also change the orientation of this frame group by using the Rotate button. In the 3D tab of this window, we have the offset settings. You can move the first and the last members separately by entering offsets values into the corresponding fields here. Also, you can move the middle frames together by changing this offset value as well. Let's adjust the end conditions and insert the frame groups. Before moving on with the design, we will have the analysis. The analysis is done, so now we can continue with the design stage. We go to the design and select frame. On this window, you can see all the frame members in the model. Using the new filtering feature, we filter the members by dragging the column headers. For example, we filter the members now by story and type. This feature makes it a lot easier to work on members, especially in complex models. Also, by selecting a few members, you can check the design status of those only. We can add design status into the filtering and see the members of which the design status are not checked easily. Or, we can move the design status filter on top, and we can change the provided classification as not designed and designed members. Now, let's design all the frame members in our model. As you can see, we can effortlessly identify the members with inadequate design with filtering. Now we can adjust the design of these members. For the frame groups, there is a separate window just like the one for the other frame members. Here, we will filter these frame groups by their stories and sections. Let's check the design status of all the frame groups in our model. In this video, we covered the modeling and design of frame members and introduced some new features that will make working on frame members a lot easier. Thank you for watching. Don't forget to subscribe our channel to elevate your structural design process.